Hey, what's up, you guys? It's Marco. Haven't seen you guys in a while. Now, today I actually have something special. Recently, I attended the Countryside Retreat. It is an event organized by young people for young people to teach young people actually how to do music. So they had a bunch of workshops and courses in like jam dynamics and music production. And one of the things that happened over there was my actual lecture on practical audio engineering for musicians. Now, this lecture had the aim to introduce musicians to some of the basic concepts of audio engineering, but in a very practical way, because this is the stuff that you get faced with every time you go to a gig, every time you want to record something. So it was like very practical. It was really interesting, and I kind of prepared it like really quickly, and we filmed the whole thing. So today I'm going to be publishing the entire thing so you can watch it over here. It's quite interesting. You might just learn something. Now, I understand I've been away from YouTube for quite a while. And YouTube is in a weird place. I feel like it's in a weird place at the moment, and I'm doing a bunch of things, really trying to improve all the things that I can deliver to you, but I kind of shifted my focus to like shorts and Instagram and unfortunately TikTok. But yeah, I was doing a lot of work over there, and I'm sorry for not being on YouTube that much, but I will be coming back with a little bit of a different concept in videos, maybe something that can actually offer you just more value in these videos that I'm making for you. Now, if you don't know who I am, if you're first time on the channel, my name is Marco. I do audio engineering. I build amplifiers, I make pedals, and I'm interested in a lot of different things. And this stuff actually makes me absolutely crazy. And I run the Slightly Technical Academy. You can join the Slightly Technical Academy. You can learn more about me on the Slightly Technical Academy, and I've also worked on some new things such as the Backstage FM, which is a channel. It's available on Discord where you get invited to when you join the Slightly Technical Academy, or if you use Telegram, the Backstage FM is also on Telegram. It gives a daily feed of videos where I basically created an algorithm to filter out these videos to find and extract useful videos, hopefully useful videos in this world of ours. It's kind of useful for breaking out of the loop that the algorithm creates, because I sometimes feel that the algorithm is always forcing the same videos for me to watch, sometimes hard to break from it, and sometimes you can actually miss some of these videos. Now, if you'd like to learn more, please go visit the Slightly Technical Academy. I've got my course on the Big Muff Pie. I've got the Tonex packs over there. It's all good stuff. Please don't forget to like this video, subscribe to the channel, leave the comment, all that good stuff. And yeah, now I'm going to show you the workshop that I attended, actually that I did, the lecture that I did. And I can only say that I remember that I had a little bit of a slow start because I was not really super prepared for this. I didn't have time to prepare it, but bear with me. I think it's going to be really interesting. Enjoy.
I want to talk about signal levels. This is very important for a lot of musicians to understand what kind of signal levels exist. This includes basically all instruments, everything, all the gear that you work with. Signal levels are very important to understand because if you grasp the concept, you will understand how to basically sound good every time whenever you go on stage. What that means is you will know what kind of gear you need. You will know how to set your sound up so you have basically minimal noise. When you go on the stage, if you're on a bigger stage, you will know with what kind of signal you're working with, depending on the instrument, and we're going to talk about that. And you will know what kind of basically, you will know how to give a very healthy signal to the mix engineer, and that will help you a lot on the road to sounding really good. These are some common mistakes that I see a lot of musicians, and not only beginner musicians, we're talking about a lot of musicians who are like very experienced, who make mistakes with this signal type. So I like to classify them in like 4 different groups. There are 4 types of signals, and we're going to start with the microphone level signal. So microphones are really interesting because they're devices that are going to pick up this acoustic pressure that comes out of our mouth or whatever, a guitar amplifier, for example. And microphones are actually very weak So the signal that the microphone gives is like very, very weak, depending on the microphone, but generally it is a very weak signal. When you have a weak signal, that's called the microphone level signal, right? When you have a very weak signal, that signal is subject to a lot of interference that happens. For example, here you have a lot of cables. Sometimes you would have some power cables, and if you run, for example, a power cable that's powering a speaker or something like that, and you run a microphone cable close to that power cable, that microphone cable will pick up the noise, pardon me, from the cable that's running a lot of current. So microphone level is one thing. Then we have instrument level. This is yet again a very weak signal, usually a very weak signal. This is, for example, a signal that comes from an electric guitar. It is also weak like the microphone level, but it has a little bit of a different impedance, and if we have time, we're going to touch upon that topic as well. It requires a little bit of a different preamplifier, but it's also a weak signal. So after these weak signals, so the microphone and instrument level signals, we can talk about the line level signal. Now, line level is a little bit different. Line level is much stronger in terms of amplitude, stronger in terms of voltage, also has a different impedance, so maybe we're going to talk about it. It's a little bit more complicated. I don't want to, bug you with this at this point. But what happens is that when you plug your guitar in, for example, in a preamplifier, the preamplifier is going to raise that small signal. It's going to make it stronger. It's going to bring it to line level. Now, there are different standards in line level signals. There's the professional level, there's the consumer gear level. What happens is that you use line level signals. Line level signals actually happen after some kind of preamplification. For example, can anyone tell me what kind of level of signal do these devices, keyboards, synthesizer, what kind of level?
Line, supposedly.
That's line, exactly, because it has some kind of piece of electronics that is going to buffer that signal. It's going to bring it to a certain level. It's going to drive that signal. And a good thing about line level signals is that even though you're going to use the exact same cables, we're going to talk about cables a little bit later, but even though you use the exact same cable, you can run a much longer cable without the signal getting any kind of interference from all this stuff that's happening around. There's a lot of stuff happening around. There's a lot of lights on stages. There's a lot of other different cables, but line level signals are cool. Now, what we need to take from this is that if we have a microphone level signal, or if we have an instrument level signal, we don't want to run the long cable because it's a weak signal. What happens is some kind of degradation happens. When you use a longer cable with guitar, it kind of changes the sound. Sound becomes a little bit duller, a little bit darker. Now, yes, there's the talk about a lot of different expensive cables and all that, but that's a little bit of a different topic. But a lot of bass players, for example, use passive pickups and they run their cable directly into a DI box. Now, the DI box, a lot of the times, is going to create some kind of line level signal, and we're going to get to DI boxes as well. So, after talking about this line level signal, which is supposedly this middle ground, it's a nice signal. It's not overly strong, it is not overly weak, it is a great signal that can travel a long time, a long length. And there is only one more group of signals that is left, and that's speaker level signal. Now, speaker level signals are different, and speaker level signals come out of the amplifier. Speaker level signals can also be a little bit dangerous. We can also mention that. That is basically the signal that comes out of your amplifier. For example, we have guitar players. Guitar amplifier is connected to a speaker with a cable. Through that cable, you're going to have a speaker level signal. Now, speaker level signals are great because there's a lot of current passing through them. Basically, they have low impedance, they can drive a lot of current, and they're also not susceptible to noise because they're basically strong. So you can run them quite some distance. And we're, again, not going to get into audiophile stuff and people who are working in hi-fi because they talk a lot about this. But the concept is that you have basically 4 groups of signals, and they are all of different amplitude, and you need to understand this so you would know if, for example, your guitar sound is a little bit dull, maybe you need a preamplifier or an amplifier that is closer. You would plug it with a shorter cable. If you have a device such as a synthesizer, you know that you have a line level signal, you can drive it a longer distance. And yes, we use DA boxes, but we're going to get to that. Basically, 4 different levels of signals. And I just want to go back to the microphone and instrument level. A lot of people find that a little bit confusing because both of these signals are weak. But there is a difference to what kind of preamplifier you need for a microphone. So it's not the same. A lot of people do ask me, like, can I use this guitar preamp for a microphone? Well, you know, technically it is not the right choice, even though sometimes maybe it can work out, but it is not the right choice because it's a different architecture of electronics that drives that specific signal. Now, can anyone tell me what is the difference between polarity and phase? So basically, if we have a very simple concept, so normally when we describe sound, we would describe sound with a sine wave. Now, a sine wave looks like this. That's super simple. And usually people, when they want to address some things regarding sound, they would use a sine wave as an example because this is the simplest possible sound according to a certain school of thought, let's say it like that. But sine waves do not exist in nature, never. Sine waves we can generate them, we can use them as part of audio and sound design and sound synthesis, but they don't really exist in nature in this pure form. Sine waves are very, very simple. It is only, basically, if you can imagine, that's only one frequency. There are no other frequency components. It is a very simple sound. Now, a sine wave can look like this, but it can also basically look like this. And the difference between these two sounds is that if you're listening to any of these sounds on their own, there's absolutely no difference because our ears do not register phase. We do not register phase, we only register phase in correlation to some other sound. If you're listening to a sound on its own, if I would play you an example of a sine wave, which starts, let's just say, a sine wave that first goes to the plus region, let's call this a plus region, this is a minus region, and the sine wave goes around 0, just for a simple example for an explanation. If you would hear these two sounds, they would sound exactly the same, but what happens is, that if you would play these two sounds simultaneously, they would interact. They would either interact inside of the system, the audio system that you're working with when you're making some music, mixing. They would also interact with the room. That's a little bit more complex because sound is reflected from the walls and a lot of weird stuff can happen. But basically when people talk about polarity, and recently I posted something on my social media and there's a lot of very nice people who comment stuff, very knowledgeable people, and they started arguing about whether should I say phase or should I say polarity. Now polarity is very simple. If you have a battery, there's a plus and a minus. That's a polarity. It's basically just telling us you could potentially say that these two signals are of opposite polarity. You would also have a polarity switch on mixers, which is sometimes useful because if you're using multiple microphones, you would use the polarity to basically just flip the signal. We're going to get to these concepts, but phase is a little bit different. Phase tells us something about what's happening with the sound in the time domain. Because phase doesn't need to be like this. Here we have an example of a sine wave that's flipped. That's 180 degrees out of phase, right? But it can also be 90 degrees out of phase. It can be 37.5 degrees out of phase. And it becomes really, really complicated. Now, if you can imagine, you never use sine waves, you always use complex sounds in nature. What happens is that all these frequencies, all the sound components are gonna start interacting. And not only that they're going to be interacting in amplitude or what kind of frequency spectrum is there, they're gonna be interacting with this phase. What happens is that if you have two things that are 180 degrees out of phase, they do cancel themselves out. Basically, if we would play this, for example, as an example on a mixer, computer, whatever, you play these two sounds simultaneously, you would hear silence. Because as this one wants to go up, this one wants to go down, they end up being in 0.
Is that how noise cancellation works?
That's a very good question, and yes, although it's a little bit more complicated. It's a little bit more complicated than that because of this complex interaction of sound. Noise cancellation is usually used in earbuds, stuff like that. And normally, I'm not an expert in this, I have to say, but as far as I know, they do use a little bit of that microphone sound, and then they sort of flip it out of phase, but they also do a very complex, let's just say frequency filtering, so they don't flip everything out of phase, so they make it sound good, actually. So it's a little bit more complex, it's not that simple, but yeah, that's how they would basically select the noise, and then they would flip the noise out of phase. And we're going to be using this concept a lot in some of the stuff that we're going to be talking about in this workshop. We're going to see how much time we have, because apparently I can talk about this stuff for a very long time, and I don't want to make it like super complicated.
Do you want to turn on the lights?
Maybe that's not a bad idea. All right.
Does it work? Does it work like?
Yeah, like this.
Yes, very good. So one more thing that is, I'm gonna like jump ahead a little bit, but for guitar players this might be interesting. This whole phase thing is very important when you're using microphones. So when you use multiple microphones on a single thing, for example, a guitar cabinet, which is a very frequent for guitar players, as you progress in your guitar journey, you're going to be using a lot of different gear, you're going to be using different microphones. You would learn that people got a lot of great sounds by using different speakers, different microphones. A very important part in that is getting them into phase, or using the out of phase sound as a creative outlet. So that is the more advanced thing, but these microphones can work together if they're in phase, because if we have this sound and we have another sound that is in phase with this one, when they join together, they're going to multiply. You're going to get double the loudness. If they're out of phase, they're going to cancel out. Now, because guitar sound is a little bit more complicated than this, they will not cancel out completely, but you're going to lose a lot of bass. It is going to start sounding nasally. It's going to be weird. So that's very important. Very important with drums as well, when you're miking drums. For example, if you have one microphone on the snare, just an example, then you use overheads. Now, these sounds are weird because it takes this long for the sound to get from the actual snare drum to the microphone. And then you have, for example, 1 meter or 2 meters all the way to the overhead microphone. And when they play together, if that snare is out of phase, it's not going to sound good. Better switch off either of the microphones, it's going to sound better. But if you get them into phase, that's why engineers spend a lot of time. I even measure the distance, and when you get to studios, it gets a little bit weird with engineers. Sometimes they take hours to measure this distance, and you can also edit that in post-production. There's also the option for that. So phase is really important as a concept to understand in sound. You look like you want to ask me something.
I have 7 million questions. Yeah.
Okay, very good. Well, maybe something related to phase. Maybe it's not a bad moment.
Yeah, how do you realize what phase you're in from the beginning? Like how do you know at the beginning is it going towards the plus or is it going towards the minus? Or does the machine just show you?
It's actually a very good question. And actually, it's sometimes a little bit complicated, especially for people who used to work in audio, for example, 40, 50 years ago. They didn't have Pro Tools, or they didn't have these digital audio workstations where they would graphically see this. Because, for example, today, it's very simple. You can actually zoom in into the waveform, and you can see if it goes upwards or it goes downwards first. And yeah, the weird thing is, because we use a lot of different gear from different brands, sometimes this gear is engineered differently, and sometimes what happens is that the output of that gear is going to be in opposite phase. Especially with audio gear, it happens that, for example, if you're using some kind of processing unit, if you're using some kind of amplifier, because it has a lot of gain stages usually in amplifiers do flip the phase multiple times, and then what you end up with in the end, like, you don't know what that is. And sometimes you can play 2 amplifiers, but those 2 amplifiers work out of phase, and they sound like shit. Absolute shit when played together. If you flip the phase on the input or on the output, usually on the input of these two amplifiers, all of a sudden they start working together, because basically as one is pushing the air, the other one is going to be retracting the speaker, and they're sort of working against each other. When you get everything into phase, they all start working together. So that's only an example with guitars. Now before, well, a lot of the times people would just measure. Especially with microphones, they would measure the exact distance between a certain instrument and the capsule, and they would sort of get it into phase. There is also the noise trick. A lot of producers use the noise trick, for example, to get stuff into phase. Like they would play white noise.
Oh, yeah.
They would play white noise, and then they would get it into, you know, they would move the microphones until it sounds good. And then...
sorry for interrupting. I played in a band for 6-7 years, and the guy who was making our sound at the rehearsals, he had this thing where he puts on a really loud white noise.
Okay.
And then he works something on his iPad.
Okay.
For like 5 minutes, and then he's done. And I never heard the difference. You know, it's just white noise, really loud white noise. But he's doing something, and when he finishes it, he's
Yeah. Well, basically today, because we have these amazing devices, we can actually graphically see some of these things, and sometimes you can do it. For example, if you work in live audio, it is also very good practice. For example, when I come to work as a live audio engineer, there's a lot of people in the restaurant, for example. We don't want to do a 1 hour long or 2 hour long sound check, so I like to prepare everything, and then sound checks usually last 5 to 10 minutes, because I can take care of a lot of things today with these devices, basically using the PFL, just using graphically, looking at, for example, the spectral analyzer, really depending on what kind of gear you have. But essentially, sometimes it's really tricky. You don't know the phase of a certain pedal. You've got guitar pedals that flip the phase of the input signal. You've got guitar pedals that give you the exact phase. A lot of manufacturers don't pay attention to this, because really it's not that important unless you use two pedals in parallel at the same time. Only then you would hear the difference. But essentially, in most cases, you don't really need that. And the only thing that you have on the mixer is a polarity switch or the phase flip switch. People like to argue about the terminology, but basically if you use the phase switch, it's going to flip the signal 180 degrees out of phase. A lot of the time, that's going to fix the issue. Or at least it's going to fix the issue to some extent. Sometimes it's not really necessary to make it perfect. It's just good to get it. It should sound good in the end. We don't really care about making everything perfect. A lot of times you can use, especially for guitar, I don't want to go on a tangent, but you can use phase as a creative outlet, because sometimes you can use two microphones that are slightly out of phase to get a slightly scooped sound, a slightly nasally sound. You can end up with a very interesting guitar sound. Also guitar pickups. At guitar pickups, a lot of the times, these pickups are out of phase. Stratocasters, if you use positions 2 and 4, these pickups are essentially electrically out of phase and also magnetically out of phase. They cancel out the they cancel out the noise, because noise is in phase. So it cancels out the noise, so the sound is better, like less noisy, but you also get a quacky sound.
yes.
And that's because you get less bass in that sound, because it's out of phase. So phase is very interesting, but we're going to get more into that. So does anybody else have a question regarding phase? Maybe it's not a bad moment. All right, so next thing that I want to talk about is cables and connections. This is very practical, very useful. We use cables to connect our stuff. Usually when you go on stage, you're going to see, I don't know, maybe 3-4 types of cables. That's mostly you're going to see XLR cables like this one for the microphone. I'm going to use guitar cables or instrument cables like that one. And I also have some examples over here. I brought it in my little box over here. Let's first talk about the jacks. There are two types of jacks. There's the TRS jack, and there's the TS jack. Now, when we connect our sound, our instrument to any kind of system, basically we have to accept that we need two wires. I don't want to get into the details to talk about everything from the beginning, but basically we need two wires for our sound to translate from point A to point B. When you have a TS jack, you're going to use a cable with two wires because this jack actually has basically two connections. If you can see this black layer over here, it is, I'm going to draw this very quickly. What happens with this is that you have a connector that is going to connect. Let's just imagine that this is our connector. And then here it has a little bit of an insulation layer, and then we have some kind of tip right over here. One wire is going to be connected here. It is going to be insulated from this part, and one wire is going to be connected here. That's how your sound is basically connected between the guitar, for example, the guitar, and the mixer or the amplifier. Now this concept is important because a lot of people have never seen a cable. They've seen a cable outside, right? But they've never seen how the cable looks like inside. And I brought you some examples so you can actually see because I took the insulation out. What happens is that TS jacks are very popular. They're used for simple instruments. You can connect a lot of different things with TS jacks. A lot of people also call this the mono connection because with two wires, you can only connect basically one sound. It can't be stereo. It doesn't do anything special. It's just one sound. Sound of a guitar, sound of something else. Here's this, maybe you can check it out and give it to the rest. That's the TS jack. So it's a tip sleeve jack. Now there's another type of jack. It's the TRS jack. It has another insulation layer here, so you can connect something to this part over here. And this type of jack can be used with 3-core cables. Now this is super interesting because we're going to talk about something that a lot of people mess up, unfortunately, but I think it's an interesting concept at least. So what happens with this type of cable, and you've probably seen this, a lot of times you would connect some kind of synthesizer, stuff like that, you're going to connect with a TRS jack. It uses a 3-core cable, so you have 3 wires. Now, can anyone tell me how many wires do we need to connect a microphone to a mixer? How many wires? Okay, 3. Anybody else? 3, 4, 5, 5, 6.
2 maybe.
2 maybe.
Is it 3 because of the XLR cable having 3?
So the XLR cable has 3 wires. Yeah, but for dynamic microphones, we need only 2 wires. Only 2 wires, because it is a very simple signal. Now, what does the third wire do with a dynamic microphone? It does nothing. It's basically connected to this part. It's connected to ground. Actually, in XLR cables, pardon me, it's not connected to anything usually, but it is just there for when it's needed. When is it needed? Well, you've heard of condenser microphones and you've heard of phantom power. We're going to talk about it a little bit more. Now, this third wire is going to transfer this phantom power. That's super, super great. That's why you use XLR cables. And even though you're not going to use the third wire, it's there. So XLRs are, I've got a few more cables here, and I want to show you some of the examples because, for example, this is a 2-core wire, or actually this is a 2-core cable. It has 2 wires. But what's interesting about this is because we talked about signals, we're talking about weak signals, a guitar signal, a microphone signal. They are susceptible to noise. They're going to pick up a lot of noise. So people were quite smart. What they decided to do is that they made one wire as being in the center, it's like the core, and then they used another layer of wire and wound it around this central wire, because that outer layer, or the shield as it's called, is going to be connected to ground. It is going to serve as protection for the wire where the signal plus essentially is going through. That's super important for guitar cables because sometimes you can use another type of cable for guitar. It's going to sound like shit. That is, for example, a speaker cable. We're going to talk about it in a second. So this is an instrument cable. You can go check it out. And I also have here another type of cable. I also took some insulation off so you can see how this piece of copper, as being the other connector, is essentially wound around. It is going to be, in the grand majority of cases, connected to ground. We're going to talk about grounding also. And it is going to protect the inner two wires, because here we have a 3-core cable. It is going to protect these wires from the noise. That's very important, because if you don't have this, or if this insulation, this shield breaks, then your signal starts becoming noisy. And that's when you usually buy a new cable. That usually happens when this insulation or this shielding breaks. So this is a microphone cable. It's used for XLRs, and it's also used for TRS jacks and stereo cables. Now that's my favorite topic. So stereo cables. A lot of people talk about stereo cables. You would go in the shop and you'd be like, I need a stereo cable. Now, here's a very important concept to understand. Stereo cables do not really exist. There's the so-called TRS cable, or the microphone cable. That exists. But you can use it for stereo, or you can use it for something called balanced connection. Now, does anyone know the difference between balanced and unbalanced connection? Anyone?
Balance should be more stable. So
should be more stable.
yeah, the sound should be.
Yeah, and that's why we sometimes use the iBox to turn unbalanced sound into balanced one.
That's correct.
For longer distances and so on.
That's correct. You are also correct, but I'm gonna fill you in. So here's the thing. Unbalanced connection is what you have from your guitar. It is simple. It has actually two wires. One wire is going to be connected to the hot of the pickup, one side of the pickup. The other one is going to be connected to ground, usually to all metal parts, and we're going to get into that. But what happens here is that with unbalanced connection, even though you have this wire that is wound around your central core and so on, it is still susceptible to noise. It helps a lot, but it's not perfect, right? So what happens is that people came to a very to an extremely good solution, and that is balanced connection. Now, for balanced connection, we need 3 wires, and we need TRS jacks, or the stereo cable, as it's unfortunately called. Now, what happens with balanced connection is that some devices have a balanced output, the iBoxes as well, but the way how that works and what you achieve is actually great. Because you have essentially this shielding wire that is going to be connected to the ground, you would have 2 wires free to drive the signal. Now, we need 1 wire to ride the signal on the way, but what does this one do? Does anyone know? I guess, all right, so these devices that drive balanced connections create one more, like a copy of your signal, and they flip it out of phase 180 degrees. So what happens is that as you would have now 2 signals, right? One is in phase, in basically this phase, and the other one is going to be, I don't know if you see this. Yeah, thank you. Great, thank you very much. This one is going to be 180 degrees out of phase, but as it travels on the stage, it's gonna pick up a lot of shit, a lot of noise from everything, usually radio interference noise, stuff from lights. The thing is, what both of these signals that are connected to the tip and the ring are going to pick up the noise, and the noise is going to be in phase on both of these signals. And what happens is that you need a mixer or any kind of device that can receive the balanced connection. And what it does, it receives both of these signals, which are out of phase, and then flips one of them back to be in phase. But what happens then is that the noise on one side is flipped out of phase and canceled out. So you have no noise. And you have twice the signal. So the amplitude of the signal is going to be 6 dBs louder. because it's twice the voltage. That's why balanced connection is always louder, as you said, more stable. Essentially, it's not really about stability, but it's gonna be louder and it's gonna be free from noise. That's why balanced connection is very important. For balanced connections, you need TRS jacks, you need 3-core cables. For unbalanced, you need the mono solution. Now, just one thing about the stereo. Yes, you can use these things for stereo because a lot of times, for example, use your headphones. Headphones have this. You've seen they have two small black basically rings on them. That's because one of the wires is going to be the left headphone, the other one is going to be the right headphone, and the third one is always a ground connection, but that's unbalanced. So you're going to get stereo, but unbalanced stereo. If you want to get balanced stereo, what do you need then? Can you tell me?
2 of those.
2 of those. You need 2 cables. That's good. So any questions regarding this so far? We're good? So one more type of cable that I want to mention here is this cable. Based on the color, can anybody tell me what kind of cable is this? This is a speaker cable. Now, speaker cables are sometimes tricky because sometimes they look exactly like instrument cables, but they do not have one of these copper wires wrapped around the other. They go next to each other. This is a very basic example of a speaker cable. If you go into hi-fi audio, they make a lot of weird speaker cables for various reasons. But if you would connect your guitar with this, it would pick up ridiculous amounts of noise. And one more thing which is important about speaker cables work on speaker level. So they don't work on instrument level like those. They don't really care about the shielding because it's a stronger signal. It doesn't need to be shielded, not necessarily. But they can carry a lot of current. If you have a 200-watt amplifier, it can zap you if you touch these cables, these wires actually. It's a lot of current and they get hot. So never use microphone or actually instrument cables for connecting speakers, because what happens is that those cables usually have very small amounts, like they're very thin. The copper inside is very thin. It gets hot, it melts, it breaks, and then it can damage your amplifier, and it's not a very good solution. I understand that sometimes what happens on stages is that people don't have the right cable, and then they would be like, give me that instrument cable. You would plug your guitar amplifier in, yes, it's gonna work. It's not gonna sound that great. Some amplifiers can oscillate, it can cause a lot of problems, but general idea is don't do it, especially with like big Marshalls. Don't do it, it's a bad idea. So, next thing that I want to mention is DI boxes and line insulators. We've already mentioned DI boxes and we do sort of understand the concept. Now, can anyone tell me why do we use a DI box?
For unbalanced signal.
Okay, so...
So if we have a weak signal, it makes him stronger.
Okay, so
it be on the level with the rest, probably.
Well, you're close. Okay, anybody else? Direct injection. Direct injection. I mean, the name is okay, but it's not that impressive, but everybody uses DI. When you have these devices, for example, this Line 6 HXFX, a lot of times it has like a DI connection. I don't know if this one has it, but a lot of guitars...
It doesn't, but it works for me. I'm not using that long cables, so the sound is decent. And
no, I'm just mentioning that because there's a lot of devices that offer now this balanced connector. Usually,
some versions of the Line 6 FX pedals
have
the
yeah.
DI out.
They basically make your signal a line level signal.
Sometimes. Yes, sometimes, but it really depends on if it's active or passive. The main... well, let's just say that DI boxes do multiple things. Depending on what kind of DI box you have, there are different brands, they do different things. But the main idea is to insulate this signal and to make it balanced. A lot of passive DI boxes, they can also make a balanced connection. It is done with a little transformer inside. But it is something called galvanic insulation, because if you have some grounding problems, which we're going to be talking about, this DI box can break that ground connection and you're going to lose the noise, essentially. A lot of DA boxes have a phase switch. And Yeah, it can help a lot. And yes, a lot of active DI boxes do raise the signal level. So they pump up the signal and you just use it to get your signal across the stage, for example. So if a lot of bass players, I understand guitar players don't really use DI boxes, even though they should with some of the pedal boards. Yeah, for sure. But bass players, a lot of bass players, they would use directly DI boxes go into the mix. That is a typical thing that they would use.
I have a question. Apparently, I have a problem. Sometimes I get a noise from my keyboard.
Okay.
And I bought DI box, and it, for most of the cases, vanished. So it solved my problem.
Okay.
But if I understood correctly, keyboard is line level, right?
Yes, and that is actually a very good topic. I don't know how we are on time, but I'm gonna do my best so we make the most of it. All right. So, because I don't want to go on tangents, but it's a very good question. Here's the thing: a lot of the gear that we use every day, it has outputs, and usually people don't read the manual, and usually people don't understand the manual. But there is a part of the manual that says specifications, and in the specifications they will tell you that it has like a balanced output, it has a line level output, but line is like a broad spectrum. If you use, like, for example, if you would use old gear from the 80s that was used by guitar players, it worked with very hot signal. It was not standardized back then, and the line level was like maybe sometimes in 10 volts or something like this. Not really 10, but it was a lot higher. Line level voltage is like usually 1 volt peak to peak as a standard now, but a lot of devices have, let's just say, a lower voltage. The line level is actually weaker than the one that you would get from the DI box. So the DI box actually fixes the problem because it makes the line better, makes it stronger, it makes it noiseless. So a lot of devices that say that they have like a DI out, sometimes that DI is not that good. You know, they do that for marketing purposes, and sometimes it's not that good. And a lot of times in studios, people actually use specific DI boxes because they do have a sound. Some more, it doesn't have to be a more expensive DI box, but sometimes certain DI boxes do have a tone to them, right? And I mean, musicians go crazy with this stuff, but it's absolutely true. They sound different.
Yeah, sorry for interrupting, but there was only one time in my life where I really felt the difference while using a certain DI box. That was a radio J48.
Yes.
And it was unbelievable.
Yeah.
Just the DI box, it changed my tone. Absolutely.
And it can be actually modded, because I have a couple of them at home, and I do mod them because you can improve them with even better electronics inside, even better chips, and it sounds ridiculously good. Yeah, so
that's the best that I've.
That's a good one, but it's expensive also. There are a lot of DA boxes that solve a problem. This is not about talking about, yes, there is obviously gear that works like this and works like that, but we do have to understand that sometimes we don't have to pay a lot of money for the gear. Sometimes what you need is a line insulator. That's also a thing that I mentioned in the beginning of this section. A line insulator is basically some kind of a device that kind of has a little transformer inside to galvanic insulate the signal, where you would input a line signal, you would insulate it from, or isolate, I don't know, in English they use insulation and isolation as well, but you would isolate the signal from a different device, and you would break the ground loops, you would have less noise. Sometimes it's also worth having just a line insulator and just separate the signal, and they're a lot cheaper. Sometimes that's enough. You don't have to use a J48 for everything, that's what I'm saying. But of course, yeah, that's...
I just tried it once and I was like, okay.
That's a very good DI box.
Yeah.
All right, so I want to talk a little bit about microphones. Can somebody tell me how, what kind of types of microphones exist? We don't have to go into like ridiculous details, but...
Dynamic and
Condenser, right. Are there any other types of microphones that people have heard of?
Yeah, well, there is those from the old phones with carbon.
Okay.
That's not, we are definitely not going to use
No,
it for
usually not.
performances. But ribbon mics.
Ribbon mics?
PSO pickups can be considered mics.
Yeah, in a way,
Not in a
exactly.
way, but that's it. So
Pardon me. Yeah, so normally we would have condenser mics, dynamic mics. We're going to use those. They're ribbon mics. Ribbon mics are a little bit sensitive and quite a bit more expensive. You're going to find them in studios. Guitar players especially like them, like the Royers, 121, 122, stuff like that. But dynamic mics are the ones that you would use frequently on stages. Condenser mics are a little bit different, and they do require they require a power supply. That's why we actually have phantom power for running condenser mics. We were talking about how many wires are required to run the microphone. When you have 3 wires, you can use the 3rd wire to run the phantom power to the condenser mic, and then it's going to work. The technology used in the condenser mic just requires power. Dynamic mics don't require power, and we just need basically 2 wires to connect them. Now, the difference in general between dynamic mics and condenser mics is that condenser mics are going to be more sensitive, and they're going to output basically because they're more sensitive, they're going to be outputting a stronger signal, let's call it like that. But since we have a plethora of microphones available, let's just say they all sound different, and certain condenser mics sound like this, certain dynamic mics sound like this, and sometimes you would also, sometimes it kind of blends, like the quality of the sound. Sometimes it's not like the condenser mic always sounds better. A lot of times when I would do gigs and then, you know, singers, they would be like, oh, I need a condenser mic. Well, you don't really need a condenser mic. A lot of the times condenser mics can create problems. Because of that sensitivity on stages, they can create problems. Dynamic mics are a little bit better because they're not as sensitive, so they're not gonna pick up all the shit around. But speaking about picking the shit around, does anybody know what are polar patterns? Microphone polar patterns. Okay, yes, polar patterns, we're talking about, exactly. So basically, polar patterns are something that tells us in what area the microphone is going to be picking up sound. So if I take this microphone, usually these microphones are cardioid or supercardioid mics, which means that basically they're going to be picking up sound in this radius right over here. So basically, if you turn it away, you're not going to be hearing me talking. It's going to be very quiet. You will only hear reflections from that wall. But basically, it only works when you point the mic like this, as you can see it, right? So that is a cardioid mic. Sometimes you have supercardioid mics. There are a lot of different, there are shotgun microphones. Shotgun microphones are great because they're very directed. You can use a shotgun microphone. Usually they use them in film or when you're recording social media stuff, you would point it a little bit away from you, but it doesn't pick up a lot of stuff around. Now you do have a figure of 8 microphone, which is another polar pattern. That microphone is it's called a figure of 8 because it basically looks like this, because it's going to pick up stuff from this area and also pick up stuff from the back. You've got stereo microphones. Before, when they were recording like pre-podcast, and because now everybody's using an SM7B for a podcast, that's popular because it looks great, but essentially it's not the best podcast microphone, let's call it like that. But when people were recording any kind of talks on radio, they would use a microphone that would record from both sides, and they sometimes record stereo for recording like instruments. We're not going to go deep into the microphone topic, but suffice to say that you need to understand that microphones do have a polar pattern. And a lot of the times when we are working in audio, especially on live audio, we're going to use usually cardioid microphones because we want to separate everybody for the mixer. You don't want your microphone, if you're a singer, picking up the drums, although it happens all the time. So that's very unfortunate. But a very important concept with microphones is something that you probably heard, and that's microphonics. Can somebody tell me what is microphonics and how do we, why it happens? Why does it happen?
Too much microphone.
Yes?
Okay.
Too much signal?
Too much signal, okay. Yeah.
I know when it happens, I don't know why.
Everybody knows when it happens, unfortunately. Everybody knows, and it's not pleasant for the audience. But let me tell you something. Unfortunately, a lot of people miss this part, and it's a super interesting concept, and it's super simple. Microphonics, it's called microphonic feedback. feedback because what happens is,
It's feedback between speaker and microphone.
exactly.
Audio receiver and audio outlet.
Yes. So basically what happens is when I'm talking into this microphone, I'm talking like this. What happens if I use this microphone and I move over here and I turn the microphone like this directly into the speaker and I'm speaking into it? What is going to happen? There is going to be a feedback loop happens between me inputting into the microphone and then also the speaker signal or the sound from the speaker is going to be input into the microphone. And that creates a lot of problems, and then microphonics starts because there's a lot of level, a lot of times when the gain is up, but also microphones are sensitive at certain peaks. A lot of times it's going to be sensitive around like 4, 5, 3K, stuff like that. And then you're going to hear a squealing sound, a disgusting sound. So that's microphonics. That's how it happens. So how do you beat microphonics?
Turn down the higher frequencies. Turn away from the speaker.
Thank you. No, but recently I had an experience a few months ago. I went to Belgrade to some club, and I went over there to help out a friend who had a gig, first time singing on a gig. So you can imagine the problem. Not a very good singer, just started singing, and the sound guys come over there. Obviously, sound guys, best guys in the world. They know everything. They're the king of the jungle, right? They walk into the room, and you've got a room that has 4 kilowatts of speakers on that wall, directed, like, angled a little bit down. And then you have a completely empty place over here with a lot of curtains, and they decide to put the band over there. So the singer stands like this with the microphone directed into the speakers. After that, we had about 2 hours of notch filtering these frequencies, which was completely unsuccessful because you had microphonics on about 20 places, 20 peaks. So, and then obviously I kind of had to step in gently and ask them to move the singer away from the speakers. So yeah, you move away from the speakers. Yes, you turn down certain, not only high frequencies, but what you want to do is you want to notch frequencies out. Because if you turn down the high frequencies, you're going to ruin the picture, you're going to, the actual audio and image. You want high frequencies. If you don't have high frequencies, the singer is not going to be heard. So there are some things called notch filters, so you can sort of find these frequencies and turn only this narrow band of frequencies, you can turn it down. There's going to be no microphonics. But if you don't turn away from the speaker, and when you have a singer who dances on stage and does this with the microphone, there's a special place in hell for these people. And there's also one more thing. Microphones are, especially these microphones that are of this concept, all microphones, not only that they do receive the sound from right over here, but they also receive the sound from this part over here. Depending on the microphone architecture, obviously some of them are different, but they do kind of receive the sound from down here, which is out of phase. That creates the sound of the microphone. That is by design. So when people do this, there's another place in hell for these people. Sometimes it doesn't work. But yeah, there are a lot of singers that do this as part of their performance, and then audio engineers know this, so they kind of have to do some things to remedy the fact that they're going to cup the mic and they're going to sing. That's what they do, or they give them a microphone that has a little bit of a different architecture that is not as sensitive to this. Some microphones are super, super, super sensitive to this stuff. So are there any questions regarding microphones or microphonics, feedback? So this is like a guitar-centric thing now. Can anybody tell me what kind, actually, what is the difference between feedback and microphonics on electric guitar? It's going to be very interesting for guitar players. So, yes, there's a difference between feedback and microphonic feedback, as it's said in English, but we call it, well, the same.
Are you referring to the practice when a guitarist directs his guitar to an amp?
Yes, I am.
That's a feedback.
That's feedback.
That's a nice feedback.
That's a nice feedback.
Sometimes.
You also have another one. I don't know. It really depends. Today, people.
I'm sorry, but I don't know not nice feedbacks on the guitar.
You're a lucky person. I service guitars, and I know a lot of that. So, but it's actually super interesting. There's the feedback. Yet again, what happens with guitar feedback is when the sound from the speakers is actually loud enough to excite the strings, it starts vibrating the strings, and the strings actually start producing these very nice notes. It's very interesting. And it happens only when it's loud enough. Well, sometimes when you have a whole shit ton of gain, but obviously you don't need actually with a great guitar, a great amplifier, if it's loud enough, it's gonna be singing. And now we can go down the road of like what kind of guitar amplifier, if it needs to be super expensive to do that. But yeah, better instruments, better amplifiers do more of that nice feedback. Basically, it catches on some of these peaks and it rings in a musical way, but it's the string vibrating. That's very important. That's the string vibrating. There's another way how you can get it. But usually younger guitar players don't have a lot of experience with this because they don't play big amplifiers. You can actually touch your speaker cabinet with your headstock and it's going to start producing feedback because the resonance of the cabinet, of the wood, is going to be translated to the actual wood of the guitar and it's going to excite the strings. It's going to start creating musical feedback, which is a little bit different from the regular feedback. It's a little bit different. It's interesting, but it's more like a clarinet, if I would have to go on a tangent, you know? But microphonics on guitar. Guitars squeal when they're not wax spotted. And wax spotted. So what happens is that sometimes the volume from the speaker is going to excite the wires inside of the pickup. So the wires that are around the magnets practically, and they start vibrating and they create this nasty feedback. That's why you need to wax spot them. You dip them into wax. And you just make them not resonate as much. If you use EMG pickups, before they would put it into lacquer to stop them vibrating. So that's the difference between microphonics and feedback on guitar. It's usually misunderstood. So one more thing. Oh, we're good. 15 more minutes. 15. 50. Dobro, može. Okay, so as I suspected, I will not have time to do the whole thing, but I also left some things out which are potentially a little bit more complicated, and also people get a little bit tired. So I didn't know what to expect. But
Are you
yes,
doing the lecture tomorrow?
no,
Okay.
no. So I want to talk about two more things. We're going to put it into 10 minutes. One of the things is gain staging, and the other thing is noise and safety, which I think is very, very important. Now, gain staging is very important. Can anybody tell me what is gain staging? So basically, gain staging is a term that is used and misused for referring to complex systems where with proper gain staging, you are going to get a very good result. That is in a nutshell, all right? So what happens is that if you have, for example, a guitar that's connected to one pedal, then the pedal goes to another pedal and yet another pedal and so on and so on. Then it goes to an amplifier. Then in an amplifier, you have multiple gain stages. What you want in most of the cases is you don't want, let's just say, you don't want the signal to be overly high or overly low in any of these places. The first thing that you do when you connect a microphone to a mixer, you set the gain. Set the gain up correctly. If you don't set the gain correctly, you can do all kinds of mumbo jumbo and equalization. It is not going to help if the gain is not set up correctly. If you have multiple devices, as I mentioned now, for example, guitar stuff, very easy to understand. Sometimes, yes, in guitar stuff, you want to overload with the volume. Sometimes it sounds good. That's called overdriving, but sometimes it doesn't sound good. What you want to do is you always want to make sure that there is the right amount of level in every stage, because what happens? if you have a small signal, a weak signal, that signal is, there's always noise in every system. Like more expensive gear has a little bit less white noise, but basically there's always noise in every system. And when you have a small signal, the noise is kind of constant always. But when you have a small signal, and when you amplify this, you're also going to be amplifying the noise. But if you do proper gain staging, what is going to happen is that you're going to have the noise like this, but you're going to have the signal swinging like this. You're not going to hear the noise because you've done proper gain staging. That's why you want to use a DI box and get it up to level. That's why you want to, even after the DI box, if it goes to a processing unit, you don't want the output from that processing unit to be low. Because in the next stage, it's going to receive a very low signal, it needs to amplify it. Also, you don't want the level to be too high, because you don't want to clip the input stages and you get distortion. So gain staging is... Somebody wanted to ask a question? No? Okay. So...
Questions, but yeah, I don't want to
yeah, it's... maybe we can talk about stuff after the workshop. Please.
Short question. So, if we talk about gain staging, for example, we have a chain of pedals on a pedal board.
Yeah.
Do we set up the gain only for the pedals that have the gain function?
No, actually, gain on pedals requires an additional workshop.
Okay.
And we talk about it, yeah, but we are talking about gain and volume are practically the same. Gain in the guitar world is usually just volume before the pre-amplification stages, so when you raise the gain you get more distortion, but that's a little bit different. Gain and volume are the same. So gain staging can essentially be volume staging. Just make sure that everything is properly volume staged. So because we're gonna, people are getting relentless over there because I guess they're hungry. One more thing I want to talk about a little bit, because there are a lot of myths regarding this, and there's a lot of stuff that's very practical when you come to gigs. Noise and power. So first I want to talk about the concept of grounding. So everybody talks about grounding or uzemlenie, like it's in our language, right? So what happens is that if you go to the outlet, you've got those metal pieces that are out there, you can touch them, nothing's gonna happen because they're connected to the ground, the foundation of the building, right? So that's grounding. And what happens is that every device over here, whenever it has a metal chassis, whenever it has a metal part, it should be grounded. Because in case of some kind of failure, you touch it, you're not gonna get electrocuted because it's always connected to ground. Now, noise happens if you have two systems. Let's just say we have two systems and they're connected to ground, but this one is connected to ground like this. This is the electronic symbol for ground, even though I didn't draw it nicely. And you have another system that's connected to ground elsewhere. You connect these two systems and always this jack is connected to ground. It is basically going to connect these two grounds. There's going to be a ground loop between them. Sometimes that can create noise. Sometimes that's a big problem. What do? You use a DI box. You use a DI box right over here. You put a DI box and you break the ground connection. So there is no ground loop. That's how you solve the problem. So that's the most frequent usage for a DI box and for the resolution of ground noise. Next thing is you've got a lot of different noises. There's a lot of whistling noises from power supplies. Today we have these LED drivers. Before we had the neon lights, we had dimmers. That's all a disaster. That's all shit, complete shit, because it brings in a lot of noise into our system and a lot of times it is very hard to get rid of. Then you have the white noise. It's the shh noise. It's actually natural noise. All devices have it. It's just usually today it's quite low. Vintage gear hisses more. So that's like the hiss. With guitars, because they're susceptible to radio interference noise, they need to be shielded, properly shielded with metal parts around the pickups and everything, and connected to ground. Then when you have any kind of interference, that picks it up like an antenna, throws it away to ground, you got no noise. So that's a noise thing. A lot of people also talk about bad power, dirty power. Dirty power, if you're playing in Novi Sad or Belgrade, you're going to rarely find it. Maybe in old buildings, power distribution is much better today than it was back in the day. But dirty power can be a huge problem. Sometimes you have multiple phases in buildings, and then when they do big concerts, they always need to separate the power for the lights and separate the power for the instruments. Otherwise, the lights, they have a lot of shit going to ground, and you can actually, unfortunately, hear it in the audio signal. So those are one more important thing, because obviously there are different types of noises. We can talk about different types of noises maybe some other time, but a very important thing is that maybe you've heard a lot of old people when some kind of audio device is noisy or it has some kind of hum, usually 50 hertz in our regions, so working like this, they would disconnect the ground in the power cable. Our power cables usually have 3 connectors. One of them is ground. They disconnected. Don't do that. You can get electrocuted in some cases. You should know what you're doing, but that is not very good practice. This is good practice. You never disconnect the ground here. For example, if this is an amplifier or a mixer, you do not break the ground connection here. You break it here. And this usually happens if you're connecting a mixer to a laptop, because laptops are not properly grounded a lot of the times. Audio interfaces, they have these DC little power supplies.
So you need to have a DI box between a laptop and a mixer.
Well, specifically between a laptop and a mixer, there are different solutions, because there are some kind of line breakers for USBs and stuff like that. So it really depends. We can talk about it a little bit later. But yet, definitely, a DI box is a problem solver for a lot of things, because you have that ground switch. It breaks the ground connection. Same thing for pedal board power supplies. You've probably heard of pedal board power supplies. And they also have ground loops. If you connect multiple pedals, then you have the isolated output pedal board power supplies that basically don't have the ground connection between these pedals, and then you basically have less noise. One more thing that I want to mention: a lot of people who play amplifiers, guitar players, they complain that there is like a voltage drop. In our distribution systems over here in Serbia, they're not that bad in most places that we play. Rarely we have these voltage drops. Before, it happened during war times, it happened that you would have a drop in voltage. Normally you would have 230 volts, it drops to 180, your amplifier doesn't sound good. These devices, they're gonna stop working most of the time. Well, that's with tube amplifiers, because they can work, you know, but they do, it compresses, it changes the sound. Eddie Van Halen, for example, he would use a variac on his amplifier, so he would lower the voltage, so he would get a different guitar sound, more distortion, and it's like more sustained. So that's playing around with power. But I just wanted to mention a few things about noise, a few things about safety. So remember never to break these ground connections. Don't fuck around with these power cables. Power should be always grounded for safety reasons. And even though I had to like speed it up in the end, but I did expect that we would have to speed it up a little bit, because there's a lot of stuff to cover. Maybe some other time we're going to be talking about more advanced concepts. We're going to be talking about some more of these things, and I thank everybody for listening. This was my first workshop, and